this related rate problem is regarding price and supply. So related rate problem answers one big question. How does the change of one variable affect the change of the other variable? Again, how does the change of one variable affect the other variable? Let's read the problem. The following equation describes the price of a unit. P is measured in dollars per unit, and the weekly supply X measured in thousands units. So for example, X equals to 5 means 5,000. So they mention two variables. P is the price in dollar, and then X is the supply in thousand. And then they also mentioned that the time is week. So the equation is 300p squared minus x squared equals to 200, and then p is the price in dollar, x is the supply in thousand. The first question is, if 2,000 units, $4 each, are available at the beginning of a week and the price is decreasing. So they mentioned the word decreasing, so that means the rate of change is negative. And then calculate the rate of change of the supply. All right, let's do it. Okay, so first of all, calculate the rate of change of the supply. So rate of change means derivative. So you have to differentiate both sides of the equation with respect to time using implicit differentiation. So the first one, you take the 2 down, so that is equals to 600p, right? And then this is with respect to time, so we have a dp dt. The derivative of x squared is equals to negative is equals to 2x, and then we have a dx dt. And then the derivative of 200 is equals to 0. So this is implicit differentiation. And then we differentiated both sides with respect to time. And then in the first question, they said that 2,000 units, right? So x is the supply, so we are not using 2,000, we will just use a 2 because 2 stands for 2,000. And then the price is $4 each. And then the price is decreasing, so we have dp dt is decreasing, so decreasing at $1 per unit per week. So this is a negative 1. What are they asking? They are asking the rate of change of the supply, so they are asking for dx dt. They don't know what it is, so let's find out right now. So we plug in everything we know. So we have 600 times 4, and then times dp dt, which is equals to negative 1, and then minus 2, x is equals to 2, dx dt we don't know, so that is equals to 0, and then the multiplication, so that gives me negative 2,400, right? And then minus 4 times the unknown. So x is already in thousand, so the 2, we will just use a 2 instead of a 2,000. So this is a 4, and then we have a dx dt equals to 0, and then the dx dt. So we add 2,400 on both sides, and then we divide both sides by negative 4, right? So we have 2,400 divided by 4, that is equals to negative 6. So that is negative 600. And then what's the unit? So dx dt is the supply in thousand. So this is in thousand units. So this is 1,000 units per week. So if you want to find out, if you want to get rid of the 1,000, so you take that, you take the negative 600, and then you multiply the 1,000, right? So that is negative 600, and then 1,000 units per week. So what does that mean? How come the unit is negative? So that means the demand, the supply is decreasing. So supply is decreasing. And then I know that there is another question. So right after this question, so let me just box this first. I'm gonna box this first. And then now we move on to the next question. The next question is, what if the price is increasing at $2 per unit per week, increasing? What if the price is increasing? So what if dp dt is equals to positive 2? So let's do the plug-in. So we have to plug in dp dt equals to positive 2. So we have 600, and then times P is equals to 4. And then dp dt, instead of -1, we use positive 2, and then minus 2 times x, so x is equals to 2. And then we have a dx dt. So that is equals to 0. So we have a 600 times 8. So that is equals to 4,800, and then minus 4, and then dx dt equals to 0. So that means dx dt is equals to negative 4,800 divided by negative 4. So you take that divided by negative 4, so you have a positive 1,200, and then this is in thousand units per week. So if you get rid of the 1,000, all you have to do is you multiply the 1,200 by 1,000. All right, so if you take that, you multiply that by 1,000. So you have this, so 1,200, and then followed by 30, and then we usually use the comma to separate every 3 digits, right? So that is more than 1,000,000 unit per week. All right, so that answers the first question. Let's move on to the next question. The next question, they said if the rate of change, let me change the color. So if the rate of change of supply is increasing at 3,000 units per week, so that will be the dx dt. So for number 2, what if the dx dt is increasing at 3,000 units per week? So since this is already in 1,000, then I will just write 3, and increasing, I will just add a positive to it, and the rate of change of price is decreasing, so that is dp dt is decreasing at $5 per week, so that will be -5, and then calculate the supply, so x is equals to don't know, and then assume the price is 4. Okay, do the plug-in. So the derivative is 600, right? P, and then dp dt, and then minus 2x dx dt equals to 0. This is using implicit differentiation, and then you plug in everything you know. So we have 600 multiplied 4, and then dp dt is -5 minus 2 times x, we don't know x, and then dp dt, dx dt is positive 3, so that is equals to 0, and then we have 600 times 4 times 5, so that is equals to negative 12,000, and then minus 6x equals to 0, so x is equals to positive 12,000 divided by -6. Let me make sure. Positive 3, so dx dt is increasing. All right, so that is increasing. Okay, so we take that divided by 6, so we have 2,000. So this 2,000 is in negative, so we have a positive 12,000 divided by -6, so that is equals to 2,000. So this is positive, and then the number is in units. Oh, this is in negative then. So we have a 12,000 divided by -6, so this is in negative 2,000 units. So to me, that is not realistic. So when the what was the what if? The what if is decreasing at $2. Oh, we are doing number 2, So if the rate of change is increasing, so we have a positive 3 for dx dt and a -5 for dp dt, that is the price, and then we don't know x, the p is equals to 4. So if that is the given, then this is not realistic because the number of units cannot be negative. But since this is what the question is asking, I will do it anyway. So you have to add a description at the end. This is not realistic. So don't worry about the realistic and the unrealistic part. I'm trying to write different case scenario to to cover every single possible problem that you might get on your homework and exam. So let's move on to number 3. Number 3 is what is the weekly supply if the price is $2, if the unit price is 2. So in the next question, they ask if P is equals to 2, what is X equals to? That's it. there is no rate of change. So all you have to do is you use the given equation. So we have 300p squared minus x squared equals to 200. It is not necessary to take any derivatives. So supply, don't know. Price is equals to 2. So plug in. So we have 300 times 2 squared minus x squared equals to 200. So that will be 300 times 4, so that is 1200 minus x squared equals to 200, and then we have the 200 minus the 1200, right? So x squared, that is equals to negative 1000, and then now you multiply both sides by negative, so x squared is equals to 1000, and then you take the square root on both sides, so x is equals to the square root of 1000. That is around 31 point something. So this one, if you take all the digits on your calculator, so that is 31.6227766. So 31.6227766. And then this is in 1000 units. So 1000 units. So if you want to get rid of the word 1000, so all you have to do is you multiply by 100. So if you multiply, so you take this number, so 31.6227766, and then you multiply by 1000. So that means you are moving this decimal point 3 steps to the right. So 1, 2, 3. So that is around 31.62. I will just round this up. Instead of using 22.7, I will just round this up to 23 units, because you are not happy if I give you 0.7 units, right? If I give you 31.622, that means my mission is not complete because I still owe you 0.7 units. If I give you 0.7 units, you are not happy. So how about this? I will just give you 1 more unit to compensate to meet the 0.7. All right, so that is number 3. I believe that we have 1 problem left. The last one is supply is equals to 6, don't know the price. So x is equals to 600, you don't know the price. So let's match the color. So that is in purple. All right, I will match the color for you. So that one, x is equals to 600 units, right? So supply is equals to 600. And then they are asking for the price. Price is don't know. So x equals to what? That corresponds to 1000, right? And then how about 600? So for 600, that is 1000 times 0.6. So if you take 1 times 0.6, that is x equals to 0.6. So don't worry about realistic or unrealistic. I'm trying to twist up the numbers to give you every possible case scenario. So x is equals to 0.6, and then the equation, let's recall that. So that is 300p squared minus x squared equals to 200. So you have 300p squared minus 0.6 squared equals to 200, right? And then that is 300p squared minus 0.36, so equals to 200, and then the p squared is you take the 200, you add the 0.36, and then at the end of the day you have to divide it by 300. So this one I already round this up to 0.667867, and then when you take the square root on both sides, so you take the square root on both sides, and p is approximately equals to 0.8172, and then this one is in dollars, and then for dollars, for money, so let's say $1.25, you write 1.25, right? So you haven't seen the price that is like 1.2555, right? So we usually keep 2 decimal places, so that is around $0.82, or you can say 82 cents. Either this or this. I will just keep $0.82. All right, so that is the end of this problem. If you think my instruction is helpful and clear, give me a like, share the video for me, click the subscribe button if you're new to the channel. I will see you all in the next one. Signing out.